Now coming on to these questions. Question number 1 is, what is the equation of p.d.f for Gaussian or normal distribution? It's already discussed. For normal distribution, the equation of p.d.f is generally you can write like phi of x or p of x, or some people like to write n of normal, n of not only x comma mu, like this, or some people will write n of mu comma sigma. All these people used to write. Anyway, whatever you write, the expression is simply p of x equal to, as we have discussed in our online class, 1 by sigma root 2 pi times e raised to minus half x minus mu by sigma whole square. This is equation. In this equation, you should understand these parameters also. That is, x is the observed value or result of experiment or the random variable, whatever you call it. X is those, or x is the random variable. Mu is the mean of the random variable or observation. Sigma is the standard deviation of this observation. Many things can happen. That is, in some experiments, we may not be knowing the individual values of x, but we may be knowing the mu, that is the mean. We may be knowing the standard deviation. Generally, a knowledge of mu and sigma are common in almost all the practical cases, whether you apply statistics or probability, or whether you study based on statistics or probability. Mu and sigma will be generally known, and x is the random variable. Anyway, this expression, that is 1 by sigma root 2 pi, is a factor. In order to make the area below the bell curve, you need it to be equal to 1 whenever you are talking about probability density function. The total probability is equal to unity. So in order to force this area of bell curve into 1, this multiplier is used. And also you know that the area or this bell curve is extending from minus infinity to plus infinity. So that is all about the p.d.f of normal distribution. Now the second question, what is the area under the Gaussian distribution curve? That already we have explained. Area is unity, or for that this expression is tuned like that. Now third question is, what are the x coordinates corresponding to inflection points? Is actually, it is symmetric, curve is symmetric with respect to the y-axis, and the curvature is now here it is, you can see it is positive or it is hogging sort of curve. After that this curvature red, I mean, becomes negative. Similarly on this side also, now it is sort of positive curvature or bumping up, then it is becoming negative. So the points corresponding to the change in curvature is called, as usual, we already have this knowledge on bending moment diagrams, etc. So this is a point of inflection. This is this curve which I have drawn is not that precise. Anyway, these are the points of inflection. So the question is, what is this x value? What is this x value corresponding to the inflection points? So if you try to evaluate this particular value, you can see that this value is minus sigma, and this value is plus sigma. Now continuing with the third question, we can see that the origin of the curve occurs at x equal to mu, or this point is nothing but mu, or the mean. So this is mu. From this we can see the left inflection point is point occurs at x equal to mu minus sigma, and the other point occurs at x equal to mu plus sigma. You can also write this like x is equal to mu plus or minus sigma. Okay, so how will you get this point? This one you can get it by solving the second derivative of this equation to be 0. Second derivative 0 will give you the change in slope, actually change of slope. So by substituting this phi of x, its second derivative, that is second derivative, this expression to 0, you can solve and you get a quadratic equation, and you get x equal to either mu minus sigma or mu plus sigma. And this expression, some people would like to say about this inflection points like this: it occurs at plus or minus 1 standard deviation. See, this depends on the statistician or engineer. They would like to tell like this, or like this, depending on the situation. So this point, you can see that this distance is 1 standard deviation, this distance is 1 standard deviation. So that is why they say plus or minus 1 standard deviation. And one more thing to be noted is the unit of all these mu, x, sigma, or given in this particular expression, all the units are same. Suppose you are making an experiment on wave height, your each and every expression, I mean observation xi is in meters, and the mean of that also will be in meter, and the standard deviation also will be in meter. So that is why we say these expressions are having the same units. You can also using the expression, you can verify that whether the unit is same for x, mu and sigma. So if you see the expression for mu is nothing but sigma xi by n, where xi is the observation, n is the total observations, and the expression for sigma is equal to square root of sigma all xi minus mu, the whole squared by n. This is the expression for standard deviation. Now let us check the units of this mu. So xi, unit of xi means unit of observation. For example, wave height, all the wave heights added together. So you'll get a big meter. If meter is a unit, so that meter divided by the n is a number, say 100, will again be meter, or the unit of x and mu are same. Similarly, in this expression, inside the square root n is a number, so this so leave about the unit of that. This unit of this and this are same, xi meter, mu also meter, so the difference square, difference is also in meter. Suppose xi is 1.5 meter, mean is 1 meter, so the difference is 0.5 meter for one of the observation, square and root of it, so meter itself. So from this we can see a unit of x, mu and sigma all are the same. So due to these reasons, some engineers or some statisticians or some scientists would like to speak that the inflection point is at plus or minus 1 standard deviation. So that means whatever we mark on the unit, on the x-axis, they are having the same unit. So there is a meaning for this distance, as said by plus or minus 1 standard deviation. Now coming on to the fourth question, what is the first derivative of, or where is the first derivative of this particular curve? So you can see the first derivative, it's a symmetric curve, that is normal distribution. This is the equation, symmetric curve. So just by observation, answer to the fourth question, you can directly say it occurs at x equal to mu, that is the population mean. At this point, I would like to mention, of course, that is not necessary anyway, but I just want to tell you, because you are all in future also will be dealing more with the statistics. So let me tell you that there is a small difference between this mu, even though expression is one and the same. Difference between mu and x bar, notation difference only. X bar and mu expression is one and the same. Okay, x bar and mu expression is one and the same, but x bar corresponds to sample mean, and mu corresponds to the population mean. Both expression is sigma xi by n. If the xi's, all the xi's is corresponding to x1, x2, x3, etc. are corresponding to a sample taken from the population, so then that is called x bar. Or otherwise, if you are taking all the xi's from the population, or then this expression will lead to the population mean. So in statistics as well as in probability, there are situations where only sampling is possible. So situation with sampling only. There are situations with only sampling is possible. There are situations where the full population can be taken. Examples are many. Almost all the engineering problems we can have only sampling. But in some of the, say for example, study like census, etc., the government urges us to take the full population. But in engineering, that may not be possible. Suppose you are making a axle of a particular machine, and you need to find out the strength of the axle by experiment. Strength finding is a destructive experiment. You have to fail the sample. So you cannot resort to a population study, because if you break all the sample, then what is the output? So you can select only a sampling. Say you are making 1,000 axles, you select 5 or 10 or 2 or 3 to break it, to study about its strength. So in that case, in the factory, you are dealing with x bar, and there are cases where you deal with mu. In the case of p.d.f, what we aim is at obtaining mu. What we say that okay, mu is available. That is a typical assumption justified by some other reasoning. And also in some studies, mu will be nothing but x bar, even though you should understand the difference between the two. in PDF or statistical or probability studies, we will be assuming we don't know mu, but we assume that x bar is nothing but mu, like that. So anyway, that is just I just wanted to tell you regarding the difference between x bar and mu. It's required information. So the answer to the fourth question is x is equal to mu, where the first derivative is 0. So now coming on to the fifth question, I mean standard, normal and Gaussian distribution. So fifth question. So Gaussian or normal is as we have just now discussed, which is having, you can even express it, some people would like to express it like this instead of written here mu and sigma. Some people would like to use mu and sigma squared, which is a variance. So this is normal distribution, and standard standard distribution is, if I use a symbol say S for the time being, is same n but with 0, 1, that is the in the standard normal distribution mu is equal to 0 and either sigma or sigma square is equal to 1. So that is a difference between the two. So you can write this expression is already known. I have written it here. So expression for S is, or standard normal is, S is given by, or S of x or P of x, whatever you write, is given by 1 by root 2 pi e raised to minus half x square. So now the standard normal distribution, this is of very use in applying calculations and or some tables, if you require, is generally made available in this standard normal format, and you can, by knowing the value of mu and sigma, you can simply put, project it to the original normal distribution. And also just as a norm of writing these things in another fashion, suppose a normally distributed variable is generally expressed by n of mu sigma square. So if you see a abstract expression like this, x is n mu sigma square, means this is a random variable that is distributed normally with parameter mu and sigma. Similarly, if you see another x or x1 like this, even with n we can write 0, 1. This means the x1 is distributed with or x1 is a random variable which is corresponding to, which is having a distribution of standard normal. So this is the difference between normal and standard normal.